Something massive is happening beneath Turkey right now, and it's not a sudden explosion or a single disaster. It's slower, quieter, and far more unsettling. A whole region of Earth is stretching, thinning, and slowly pulling itself apart. Why did scientists miss this for decades? And what does it mean for the future of our planet? Let's break it down. Turkey is quietly tearing itself open. Not overnight, not with one dramatic crack, but slowly, year after year, right beneath people's feet. For decades, no one realized what was really happening. Scientists believed they understood Turkey's motion. They thought it was simple, clean, and predictable. But new discoveries revealed something much stranger and much more alarming. What researchers found didn't just change how we see Turkey. It changed how we understand continents themselves. And to understand why this discovery shocked geologists, we first need to zoom out and look at how Earth actually works. Earth's outer shell, called the crust, isn't one solid piece. It's broken into huge slabs called tectonic plates. These plates float on a hot, soft layer deep below the surface. They move extremely slowly, usually just a few inches per year. That sounds harmless, but over millions of years, those tiny movements reshape entire continents. Turkey sits in one of the most uncomfortable places on Earth. To the north is the massive Eurasian plate, to the south is the African plate, and from the southeast, the Arabian plate pushes in constantly. Imagine standing in the middle of a crowded bus while people on all sides keep leaning into you. That's Turkey's position on the planet. For a long time, scientists believe Turkey survived this pressure by sliding sideways. This sideways movement happens along what are called strike-slip faults. In these faults, two blocks of land grind past each other, much like hands rubbing together. Turkey has famous examples of these faults, especially the North Anatolian Fault. This fault has caused devastating earthquakes and is one of the most studied fault lines in the world. The sideways motion idea seemed to explain everything. Pressure builds up, the land slips sideways, earthquakes release the stress, and the system resets. Case closed, or so everyone thought. But geology rarely follows neat human-made rules. Running beneath central Turkey is a long fracture that cuts through farmland, dry plains, and ancient lava fields. This fracture didn't behave like the dangerous sideways faults, so it stayed mostly ignored. That changed when a team of researchers decided to take a closer look, not at earthquakes, but at lava. Thousands of years ago, lava flowed across this fracture. It cooled and hardened into solid rock. Much later, the ground cracked again, splitting that lava into separate pieces. Inside this lava are tiny crystals called zircons. These crystals are incredibly useful because they act like natural clocks. They trap radioactive elements that decay at a known rate, allowing scientists to measure exactly when the lava cooled. By matching lava rocks on both sides of the fracture and measuring how far apart they ended up, researchers could track how the land moved over thousands of years. What they found completely changed the story. The land wasn't sliding sideways, it was pulling apart, very slowly. At just a fraction of an inch per year, thinner than a grain of rice. But over geological time, that movement is enormous. This type of movement is called an extensional fault. Instead of grinding past each other, the crust stretches, thins, and eventually breaks. In simple terms, Turkey isn't just being squeezed, it's being torn open. And that wasn't even the most unsettling part. Other studies showed that deep beneath Turkey, parts of the crust aren't just stretching, they're sinking. When sections of the crust become too dense and heavy, they can peel away and drip downward into the mantle, the hot layer beneath Earth's crust. Scientists call this process lithospheric dripping. Picture blobs of wax slowly falling inside a lava lamp. And that's a good way to imagine it. When these heavy chunks sink, the land above loses support. The surface can rise, sink, crack, and rearrange itself. Earthquakes don't always need plates to crash together. Sometimes the ground fails because its foundation weakens from below. This makes Turkey's geology look less like a solid slab of rock and more like stretched taffy over heat, thin, unstable, and under constant stress. Turkey isn't the only place where Earth is quietly tearing itself apart. Africa is doing something similar, but on an even larger scale. Across eastern Africa, the ground is stretching and thinning along what's called the East African Rift System. This rift runs thousands of miles through countries like Ethiopia, Kenya, Tanzania, and Mozambique. A rift zone is where Earth's crust is being pulled apart instead of pushed together, and Africa hosts one of the most extreme rift zones on the planet. This stretching has been happening for tens of millions of years. It's slow enough that no one will wake up to a brand new ocean tomorrow, but it's fast enough that scientists can measure it happening right now. Africa is no longer one solid plate. It's splitting into two massive pieces. The Nubian plate sits to the west, the Somalian plate lies to the east. They're drifting apart at less than an inch per year, about as fast as fingernails grow. That tiny motion adds up. In 2018, photos from Kenya showed a massive crack tearing through the ground. The images spread fast and headlines claimed Africa was splitting in half. The reality was less dramatic, but far more serious. That crack wasn't the beginning. It was just one visible moment in a process that's been going on for around 25 million years. If we could jump millions of years into the future, we might see seawater flooding into the gap, forming a brand new ocean where land once stood. While Africa is tearing itself apart from the surface downward, another region of the planet may be breaking in a very different way. India. India has been drifting north for over 60 million years, crashing into Eurasia at about the speed your hair grows. That slow-motion collision built the Himalayas and lifted the massive Tibetan plateau behind them. But one mystery remained. How did Tibet get so incredibly high? Some scientists believed India simply slid underneath Eurasia. Others thought the plate crumpled and thickened like a sheet of paper pushed into a wall. Then a third idea changed everything. This theory suggests the Indian plate is delaminating. That means its top layer peels away and stays near the surface, helping lift Tibet higher. Meanwhile, the heavier bottom layer sinks into the mantle below. Scientists can't drill that deep to check, so they followed another clue. Gases escaping from hot springs. Helium comes in different forms. Helium-3 is extremely rare and usually comes from deep inside Earth. Helium-4 forms closer to the surface. When researchers studied gases from hot springs across Tibet, they found helium-3 leaking out in northern regions. That means the mantle is unusually close to the surface there. Farther south, that signal disappears, suggesting the plate hasn't fully split yet. Earthquake patterns in the region match this story too. So India isn't just pushing mountains upward, it's peeling itself apart from the inside while doing it. All these discoveries fit into a much bigger picture. Scientists recently built the most detailed global stress map ever created. It shows where Earth's crust is under tension and where it's close to breaking. This map was built using over 100,000 real measurements from earthquakes, boreholes, and field studies, more than double the data available just a decade ago. Stress in geology means invisible forces pulling and pushing inside the crust. These forces quietly load faults for years before suddenly releasing as earthquakes. This map doesn't just help explain natural disasters, it also helps humans avoid making things worse. Drilling tunnels, injecting carbon underground, or building geothermal plants without understanding underground stress is risky. It's like poking a sleeping dragon and hoping it doesn't wake up. Engineers now use this stress data to plan safer projects, angling wells and tunnels in ways that reduce the chance of triggering failures. For the first time, we're getting something close to a live dashboard of Earth's breaking points. And that matters because we live on the surface of a restless planet. For a long time, continents were treated like stiff boards floating on a soft layer below. Now they look more like stressed muscles, stretching, tearing, healing, and tearing again. Earth is far more alive than it looks, and discoveries like this remind us how much we're still learning. If you enjoyed this breakdown and want more science stories explained in simple words, make sure to like the video, subscribe to the channel, and turn on notifications so you don't miss what's coming next.